Thanks very much, everybody. Again, thank you, Professor Lee, and thank you, Kate Wilson, who got me invited to this to speak to you today. I'm going to tell you about the Providence Viaduct. There's a couple of people in the audience who could probably give this presentation as well. They've heard it a few times. So again, my name's Bob Paveo in the bridge section at the DOT, and one of our major projects is the Providence Viaduct, which carries Route 95 right through downtown Providence. This is a nice bird's eye view. What I'm going to do is do my best to speak to you at the same time and use the laser pointer. So here is our project. Here's Route 95 going north and south through the page. And the color, where all the colors are, that is where our bridge is. This is the Civic Center interchange. First of all, the bridge was built in 1964. I believe it was designed for about 50,000 vehicles a day. It now carries approximately 80,000 vehicles a day in each bound. So that's 80,000 northbound and 80,000 southbound. It's an extremely heavily used section of 95. Just to the north of the bridge, the numbers are approximately 250,000 vehicles per day combined. Just very briefly, the reason why we need to replace the bridge, it had a few design issues from the very beginning with diaphragms and the structural steel. Right now it causes cracks sometimes in what we call a fatigue detail location. There's out-of-plane bending in some of the connections. And as a result, we actually are inspecting these bridges every 2 months to keep an eye on all of those locations. We've actually, since 2009, we found a few new ones. On several occasions we have gone out there, ground out the welds, re-welded them, and then reinforced the connection as well. The concrete piers themselves, it was a cutting-edge technology for back in 1964. They are post-tensioned hammerhead piers, and the concrete strength is now testing as low as 3,000 psi, and they were designed for 5,000 psi. So we've discovered in civil engineering that once concrete starts losing strength, at some time in the future, it doesn't magically start regaining strength. It usually doesn't do that. And the deck, I kind of started from the middle, but the deck on the very top, the deck has reached its design life. 50 years, especially with that traffic load, is a reasonable amount of time to expect a deck to survive, and it's pretty much had it. So we decided we needed to do a major rehab, and this was in about 2007 or the early 2000s. So we realized that stitching together this old bridge that had serious structural steel issues, concrete issues with the substructures, and also a deck that just outright needs to be replaced, we estimated it was going to be in the sum tens of millions of dollars to rehabilitate the southbound and the northbound bridges. But there were a lot of other issues to consider, and again, it comes back to the traffic, 160,000 vehicles per day on the bridges. In order to rehabilitate the bridges while you maintain traffic, at best you would probably be able to rehabilitate one slice of one bridge at a time, resulting in a project that would probably take 6 to 8 years. When you were all done, you would have had a severe traffic backup the entire time. You would have spent maybe $40 million, $50 million, and your result would be that you had stitched up old bridges that you probably would have to be concerned about in not the too distant future. And on top of that, there are already traffic issues. This is one of the major traffic knots remaining right now. So then we decided to look at the possibility of maybe building a new southbound structure, which is the orange structure. In this graphic, green is the existing northbound and blue is the existing southbound bridges. And by the way, my apologies, the bridge, we call it bridge number 578. It has one number, but it's actually two twin structures. One carries northbound and one carries southbound. And they're not quite identical, but they're, for all intents and purposes. 1,300-foot long structures. Each carries 4 lanes in each direction. There are actually only 3 through lanes in each direction and then 1 exit lane in each direction. So we decided to look at the possibility of building a new southbound structure, which we would then have 3 barrels, or we would have 3 structures, and we could move traffic around and say, for example, take southbound traffic off of the blue, put it onto the orange, and then rehabilitate freely the orange bridge all in one shot. And then do the same thing take the northbound traffic and put it in the opposite direction on the old southbound, while southbound traffic was on the new Orange Bridge. That would free up northbound, and we could rehabilitate that. And then we would have 3 structures, 2 old rehabilitated ones, 1 brand new one, and we will have rehabilitated the project and taken care of the traffic much, much better. However, the brand new southbound bridge was estimated to cost approximately $70 or $75 million. So if you added $75 million plus the approximate $40 million to rehabilitate the old bridges, we were looking at about $110 million, $115 million project. We decided that we didn't want stitched up old bridges that had post-tension piers that are very difficult to quantify the losses. It would be very difficult and expensive to actually do the rehabilitation. The structural steel that I didn't mention right at the beginning, the structural steel itself is on the brittle side. We wouldn't even build bridges out of this steel these days, according to the tests. We decided that we would just go full boat. We're going to build a new southbound bridge. Once we get that done, we're going to take traffic off of the old southbound, put it onto the Orange, take traffic off of the old northbound, put it in the opposite direction on the old southbound bridge, and then demolish the northbound bridge and rebuild it. This whole project now, building the new northbound bridge and building the new southbound bridge, was estimated at approximately $150 million. So then, or maybe 160. The new northbound bridge we were going to do slightly wider than the old the new southbound, and so that project was estimated approximately $80 million. And again, these are very rough numbers. So now we are underway with the southbound construction. Anyone drive through downtown Providence and you can see the bridge directly. Does anyone drive through downtown? You guys, so you've seen the bridge. You've seen right along here. As a matter of fact, the deck is now poured, and we actually just poured the parapets as well. And an interesting note, just a kind of little side note, we used a technology called slip forms. I actually wasn't in favor of it. The contractor suggested it, using slip forms to build the barriers. So instead of forming a section of barrier, pouring it, leaving the forms there, curing it for 28 days, stripping the forms, moving to a new section, it takes quite a bit of time. There's a machine that basically just simply slides along. You use a much stiffer concrete, and it just slides along, and the barrier comes out. But it's a very tricky operation, and you need a very experienced and practiced crew to man the machine. And the contractor actually had just that. There were many examples. I called several other DOTs, many other professionals, and asked their advice. Everybody said, Bob, just say no on your project. Do not allow them to do slip forms. But the contractor actually convinced me. They did a couple of practice runs down in Connecticut. Then they did a practice run for us up here in Rhode Island. And they poured the slip forms, 2 1,300-foot runs on the new southbound bridge in approximately 5 days. That was a real big improvement and a help to the schedule. So anyway, so that was the plan. We are now under construction with Southbound. We had further considered some other considerations on this project. Namely, I made reference to the traffic problems just in general. Not even taking into account construction projects in the middle of the city. But under the best of circumstances, when there is no construction, there is a huge traffic jam in this area, and these are the issues. First, you have traffic coming into the area on 95 North from points south, like say from URI or what have you, coming into the city. And one of the first major problems right on this bridge and then points north is the Atwells Avenue on-ramp. So people come onto Route 95 North from Atwells Avenue. Many of those folks want to get to the left, and they want to continue to points north to wherever, especially to Boston or other points north in Rhode Island. That is not so bad, but the problem is people on 95 North, many of those folks want to take exit 23, either to the state office's exit or other points. They want to go to the state office complex or many other points downtown, or they want to take the exit to Route 146 and go northwest, other points northwest. So that starts causing weaving, slowing down, and there are many accidents in this area. Then the big problem happens. Route 6 and 10 North, that ramp comes right here, loops around, and it joins 95 North. It is also joined by the downtown ramp. That joins that ramp, and then it joins 95 North. And you just have more of the same exact problem. Many of those folks want to get left, and they want to continue north, whereas the people that are already on 95 North want to get to the right to take 146 or to exit 23. This causes, on a daily basis, for each commute, several miles of backup, usually approximately 3 or more miles on Route 610 North. It causes approximately 2-mile backup on 95 North, and it even causes a mile backup on 195 West, which actually isn't on the page, but 195 West, 295 North actually gets backed up all the way from this traffic issue right here. So we came up with a plan to alleviate that very problem. Now, this is kind of a big scale, but I'll just do my best to walk us through it. And Professor Lee, please let me know if I go over time, because I could talk about this for hours.
Oh, yeah.
So what we have proposed is, instead of another 4-lane bridge for the northbound bridge, we have a 5-lane bridge that is separated with a barrier down the middle. And the barrier separates 3 through lanes and then a 2-lane collector distributor road. So to start with the changes that this would entail, this is a very similar view to the previous slide. This is the Civic Center interchange. Up here is the connection between Route 95 and Route 146. So we would take specifically, not the 146 folks, not the folks who want Route 146 North, but just the state offices people on 95 North. Their exit would be back here with exit 22, right where exit 22 is here. And we would make this exit from we would change this exit from a 1-lane exit to a 2-lane exit. Many of those folks would be able to bear right and come right downtown or go to the mall, or they would be able to bear left and get onto the CD road on the new Providence Viaduct northbound bridge. Now what would happen, the folks from Atwells Avenue, they would join on, but when they get on the northbound Providence Viaduct, they also would be on the 2-lane CD road, separated by a barrier from the 3 through lanes on Route 95 North. Now, as we continue north, here's where the big move is, the heavy Route 610 ramp, which, by the way, I think is 20-something thousand vehicles a day, is the on-ramp 610 North to 95 North. When that joins on to 95 North, it actually joins the northbound corridor again on the CD road, and the barrier continues all the way to exit 23. So now these folks from Route 6 and 10 join on, and now the cross section is 6 lanes. There are 3 through lanes still for the main folks on 95 North through lanes, and 3 lanes on the CD road. And so now you have the people that are on the through lanes, they're okay. They came into the area, they just stayed left. They didn't take exit 22, they just stayed on the through lanes, and they get to flow right through on the 3 through lanes all the way through the project area. They wanted points north in the first place. That's why they didn't get on the CD road. The folks who didn't have a choice, from Atwells Avenue and from the Route 610 connector, they get on, and they are now on a CD road. They are going to want either 95 North, Route 146 North, or the state office's exit. And they will have all 3 movements from the CD road. First, they will be able to bear right on the CD road and come directly up to a connection to Orm Street, and they can either take a right and a right immediately to get into the state offices complex, or go down Orm Street, or go left on Orm Street and go to wherever their destination was. They will be able to go straight from the CD road. They'll be able to take 2 lanes straight through, go over through the infield where the old exit 23, the old state office's exit used to be, over a new bridge over Amtrak, which is a humongous bunch of headaches for me. Dealing with Amtrak is not easy. I hope there's no people from Amtrak here. And they can jump on 95 North there, or they can bear left and take an exit lane to Route 146 North as well. So they will have all 3 connections. Now, one of the main mitigating factors, one of the main things that I was worried about when I heard this whole concept, the company VHB that has offices up and down the East Coast, their traffic guys are the ones who came up with this concept. And when I first heard it, I said, okay, well, it sounds great, but you're taking the exit 23 folks and you're putting them back here with exit 22, and it sounds like you're going to end up just making a problem, taking a problem from here and putting it down here. But one of the main mitigating factors for this concept is that not all of the people, as a matter of fact, quite a few of the people from exit 23 don't have to take exit 22. And the reason being is, from the 95 north through lanes, from the 3 through lanes that are separated from the CD road, they have their own exit to Route 146 as well. So anyone coming from points south who wants to take Route 146 to points northwest, they can stay on the through lanes, just flow freely through. They really won't have to weave with anybody, and they can take their own exit lane. So that mitigates the amount of traffic that we're adding back here. And then coupled with the improvements in making this a 2-lane exit down here, it basically mitigates that impact. And then further, I was always skeptical. I'm a bridge guy. I like studying structures. My favorite classes were structures. No offense, Professor Lee. I liked highway, but I liked highway engineering, but I preferred bridge. And now I'm in the bridge engineering section. But I was just concerned. I was like, geez, guys, does this really work? What VHB did was they plugged all of these improvements into a model, a VISM model. And when they plugged it into the VISM model, and then they also projected the traffic growth out 20 years, without these improvements, the backup on Route 6 and 10 North becomes approximately 5 miles. The backups on Route 95 North are approximately 2 to 3 miles, and the backup on 195 West is 1 to 2 miles. With this concept, with this model plugged in, and they put all the traffic volumes, including the 20-year estimates, the traffic backup on Route 6 and 10 North decreases from 5 miles to approximately 2,000 to 3,000 feet each day. The backups on 95 North go from 2 to 3 miles to effectively eliminated, and the same for 195 West. It is a tremendous, tremendous improvement that will be felt by everybody who drives through the area on a daily basis. And in other words, in one way or another, it will probably improve the lives of almost every Rhode Islander and many thousands of millions of people in the Northeast region who drive through this area and take the interstate right through this area as well. We also did an economic analysis for the user costs, and we hired a company out down in Rockland, Maryland, who do things like cost-benefit analysis for large transportation projects all the time. And they estimated that the user costs will be $5 million a year if this project is built. And we decided back in 2014, now let me back up for a second and talk about money. Money is always an issue as well. Again, if we were to do, you can see the pink in this graphic is just the original scope of work. That's just replacing the northbound bridge and just doing a little bit of approach work and not doing a CD road and not doing the extra new bridge over Amtrak and all of that business. This project is approximately $150, $160 million, and we actually had hoped originally, we thought we could rehab it, and then we realized it's really not beneficial to rehab it. We actually need to replace it. This project over the next, starting a few years ago, because we've been under construction for almost 3 years now on the Southbound bridge, for the better part of 10 years, this project is going to take a tremendous amount of resources away from the rest of the needs of the state, which are many. The bridges are already in bad shape. The young lady explained that in her PowerPoint just a short while ago. Then, on top of that, to make all these nice improvements, which would be a fantastic improvement, instead of just replacing the bridge and just making the bridge safe, the extra improvements approximately add $40 million to the project. And if the user costs are $5 million a year, it's actually a pretty good investment as far as transportation projects go. But with all that said, we are moving forward at this point with design. That's what I've been told to do. However, the people that run DOT, the directors, they have some serious decisions to make because of the many, many needs, the rest of the infrastructure around the state. So it is not certain that this will be built at this time, but we do have the plan, and I hope that it gets done. And that's the presentation, and I don't know if I have any time for questions and answers, or is that it? Just yank me.
Yeah, at least we can have one if anybody has. Looks like, yeah, one question.
I can throw up a comment and you can maybe address the accuracy of it. I'm usually a bicycle commuter and on the train, but I occasionally have to drive. And then when I've been approaching Providence at, say, the 5 o'clock time, I've noticed that I don't know exactly where the backups are starting, but I start encountering them even where Route 4 merges into Route 95, and it seems to be backed up all the way into Providence from there. So
Yeah.
is that potentially even connected to this, or would that be potentially an earlier backup
No,
location?
we actually, it's funny because we just discussed some of those very issues in a meeting recently, because I went to the directors, and, you know, my job was to try to defend this extra stuff. And their answer to me was, Bob, there's a bottleneck at Route 4, there's a bottleneck kind of near the airport. Those bottlenecks are not associated with this. They're not caused by the weaving that happens right along this corridor as Atwell's joins and then Route 6 and Route 10 join. So they're not associated with that. But our answer was, if you do something like rebuild the Route 4, Route 95 connection, and then you do something else with the airport connection, you're just going to add that much more volume, and it's just going to get stuck that much worse if you don't make these improvements here. You know what I'm saying? So if you get rid of some bottlenecks down somewhere else, but they're just going to jam right where the plug still is. So yeah, they're not related.
So is there actually a free-flowing traffic region between the airport and there?
Yes, it's not that bad. It's not that bad as far as I know. The I-Way made a big improvement.
Okay.
Yeah. Yeah, not perfect.
Yeah.
Nothing is perfect. There's a, you know, it's a pretty heavy
I can
used
get to
section
third
of
gear.
Route 95. Yeah, that's right.
Okay.
As you know, the Bob is URI alumnus. So we are very proud
civil
for
engineer.
him to do this comprehensive project. So he deserves one cap
Oh, thanks very much.
from Department of Civil Environment.
Fantastic. I like the
Okay.
colors too.
Yeah.
Wonderful.
Yeah,
Thank you so much.
When you go out by the project, that's the one you are going to wear.
Fantastic.
All right? Thank you very much.
Thank you very much, everybody.